So I like to do this a lot in my classes rather than. In addition to trying to get a sense of how the class is doing by verbal and nonverbal cues, I really like to ask people to just give me a thumb. You can hide this thumb, but if this thumb tells me from I understand everything to please help, and anywhere in between, just how you feel about how the course is going so far, the material that we are covering, everything makes sense, and I feel like I can implement it and I understand why. Thumbs up, thumbs down would be, if we please go back and do something that we've done again in a different way so that I can get caught back up. Anywhere in between is somewhere in between that on that scale, but if that's some feedback you can give me so far, that would let me know how is the pace, how is the material that we're covering, and especially coming from where you've been coming from with the courses that you've taken, whether that's here, somewhere else, just a sense of how things are going. All right, I think I have a pretty good sense of where we are. I will continue to do this throughout the quarter and use that to manipulate the pace as needed. So last time we started our implementation of a linked list, we finished off the interface. This is going to be an interface that we will use for every type of list that we are going to create. The first one we are going to do in class, the rest are going to become your first homework. Eventually, once we finish this. So the next thing, let's say you are in charge of this. What would be the next element of a linked list that you would want to implement? After the interface. So the interface is basically done. So what is the next file that I should create? And what should that file do? Node class, I like that a lot. So we will make a new, instead of interface this time, we're actually going to make a class. We're going to implement something. I'm going to call this singly linked node. If anyone uses Eclipse, then you can see all sorts of options. I generally just go with whatever is called. If you're making a project, either in IntelliJ or in Eclipse, and there's a modulinfo.java option, always deselect that. That always creates issues if you're making packages. So we are going to make a singly linked node. As this is an object, and it is an object that is meant to be instantiated, there will not be a main method. It's meant to stand alone. We are making the blueprint for how we are going to, what it means to make a node. That node is going to have a value, and that node is going to have a reference or a pointer to the next node in the structure. Those are going to be the two important fields that we need. So let's actually go make sure that we do that. So the value that's stored, I'm going to call this data. What is the variable type of that data? Yeah. It would be an int if we only wanted to store integers in our list, but since we want to make something that is generic, what would the type of that variable be? Yeah.
We want it to be generic.
We want it to be generic, so I guess I should probably also up here make sure that the node is generic. We decided on T over E as our letter last time that we were going to be using to represent that.
Quick
Yeah.
question, because I don't think I was here for that. What's the difference between T versus E?
All syntactical. It's all just whatever. Yeah, no actual meaningful difference there. It's just a matter of you want to be consistent across your classes. So it's a design decision you make early and then carry it through. E is what is used in all of the Java documentation, and T is what is used in all of the C++ documentation. I actually honestly prefer T myself over E. I don't know why. They're both in the word the, which is the most commonly used word in the English language. Trying to make connections that don't exist. So our value, we're going to make of type T, and I'm actually going to call it data over value. You could put value there, but I feel like data is just a little bit more specific. For those of you who aren't used to really thinking about your variable names, it's something that's extremely important because it aids so much to the readability of your program. And at some point later this quarter, maybe I will give you a this versus that program that does the same thing. One has very clear naming style and one has very obscure naming style. And it can make a huge difference, regardless of the level of commenting that is there about the readability of code. What is the variable type for the node pointer that we want to refer to the next node in the linked list?
You said what's the variable type of?
Yep.
Node? Wouldn't it just be the singly linked node?
It is a singly linked node.
Yeah.
Singly linked node T. We're gonna call this next. And again, we're not assigning values because, of course, these are fields in an object. They get values in a constructor.
Would you want? You want the data to be void? Is that not general, if it's like the first, because this is going to be the first node in our list.
Right, so in a constructor, usually that's something you want to pass in as a parameter.
Oh.
So we could overload and allow the user to not select that and have a default value, something like a null default value. But I think for the scope of this, when you make a node, you're always going to know the value that you want to put in it, the data, and you're always going to know what the next should be. We're going to make the user put in null if it should be null.
Okay.
And that way we don't accidentally have a default where the user doesn't know that it's null, but we assigned it to be null. On second thought, we're gonna overload it. Why not? All right, so we're going to define our constructors. Again, default is to public. If you don't assign this, we can add that public there, doesn't really matter. And we're going to first do the non-default. So let's take in the data. And let's take in the next. I don't know exactly how syntactically people have done things in the past. I like curly braces on the same line so that this aligns with something that you start reading immediately rather than putting this curly brace on the next line. I don't care what you do really, as long as it's readable. So when we have names in a constructor that are the same name as the fields, how do we assign to the fields rather than do nothing? Yeah, we use the keyword this. Where does it go? Does it go on the left-hand side or the right-hand side?
It's this dot.
Yeah, so we're gonna say this dot data equals data. And what this is doing is we're just now saying that you can see it even highlights it for you. The blue data refers to the field and the brown data refers to the parameter to this function. So this is important if you give them the same name. Whenever you just refer to something by its name, you're referring to the most local version of that variable. In this case, the most local version of data is the parameter and not the field. It's the closest in to this scope. This scope is this method. So if you just name something, it will refer to whatever is defined to be data within the scope of this method. If there's something outside of that, then you need some other way of referring to it. This just stands for this object. So when we make a class of type singly linked node, when we say this dot data, we're saying this object data field. So that again refers to this data. And the assignment that we want to do is take the value that was passed in as the parameter, and we want to store it in the field. So similarly, we can say this dot next equals next, and that will do exactly what we want. I name these the same thing so that we go over this in practice. Some people really don't like parameters having the same names as fields and think that it leads to confusion. I would say if you know what you're doing, it's not a big deal. That said, if you don't want to have this confusion or worry about this at all, just make sure that you're naming your parameters something separate from your fields. That said, if it's a constructor, it does make the most logical sense. If you're passing in a parameter that's going to get assigned to the field, naming it the same thing is the clearest thing you can do. All right, that's the entire constructor. We've set both of the fields. They both have values. That's what is very important to do in a constructor. So the other constructor that we could make is if there's a data and there's not necessarily a next node, which means that we are going to just set it to null. So let's go ahead and write that. Here we have a choice. We could say next equals null, and the most local next would now refer to the field, rather than there is no local parameter. But to be consistent, I do like to say this dot next equals null. In a constructor, whenever you say this dot something, you're always referring to the field. This just makes it slightly more readable, even though it's more verbose and unnecessary. I still feel like it aids with the understanding. You don't want to have one field referred to by this dot data and one field referred to by next. Question? Because we are passing in a node here. So there are two ways that we might want to make a node. One of them is we're going to eventually connect this into a linked list. So we don't necessarily want to specify the node that it's going to point to. The default should be that it doesn't point to anything. It's a node that stands by itself. If, on the other hand, we wanted to immediately connect it to some other existing node, we could pass in that node reference as the next. And then this allows us to call this constructor, instead of this constructor, assigning the next immediately to be that next, and it saves the user a line on their own program. The fact that this exists, yeah.
We just do this parentheses data mode and parentheses and save alone.
Yeah, you could.
Would we be able to just set it to null, the next to null, originally with the first construction? Or do we?
Yeah, so sometimes we'll see this when we make some of the nodes. It's not always just because it's the tail. If you're doing an insert into the middle of it, we don't necessarily know yet what the next node is going to be. Maybe we do. Depends on the situation. So I would argue that we probably could get away with only having one of these constructors. It actually doesn't really matter which one it is, but I think this will make the life when we go try to implement everything just a little bit easier when we have those options. We'll be able to make it as simple as we possibly can. Good questions, though. I prefer to make the tool more verbose so that when we go to write something that uses the tool, that is what as simple as possible.
One question. So in the second document, you have like T data, and you don't have next.
Right.
You explain why you don't have that in the
Yeah, so. This is closest to empty. Feeling blue today. When we make a node, we know a node has two components. It has this data and it has a next. When the user wants to make one of these, they may know two pieces of information. They may know the data and the next. They may also only know the data, what I want to put there. The default for this is that the next should point to nothing. This should be null. So this allows the user to not have to call this constructor passing in null for this. They could just pass in the data without that second parameter. And that allows the default of null to be done in fewer characters and with less confusion, I would argue, if you overload it for the user. But that was my thought earlier in the class, is do we really need to have both of these? And I think for ease of eventual use, the answer should be yes. But it is very possible to do it with just one. This just gives you a default value that says, if you just pass this one piece of information, you want a default linked node with whatever data is passed in. If we do know that there is some other node that we want to connect to, rather than have this be null, we can now call this constructor instead of that constructor, passing in this node. And now instead of this being null, this will point at that node. Gives us two different ways to make a node. A default way where this is null, and a non-default way where we pass in that next node. Other questions before we move on? What else belongs in a node class? Yeah,
Is push in the node or is that normally in the?
that would be in the linked list.
Linked
That's gonna
list,
be,
yeah.
if it's using the linked list structure,
Okay,
it's manipulating that structure. It belongs in the class where that structure is defined. Great question.
Wouldn't you like to have a tuition method? Because they're not giving out, you know, have a later.
Printing out a node, we could do a two-string. I'm going to argue that we may be able to just do it in the linked list. Although maybe I will change my mind and want to come back and do a two-string in a node to print out that exact value. But really, all a two-string would do here is print out the value. For a linked list, we're going to want to figure out whether a comma goes after it or not, if we're going to try to print it out as a list. So I'm going to argue that most of that logic would go in the list, but that's a great idea. That is usually the case. Yeah.
would we want an index to tell us which node in the list it is, like an index variable?
That would involve it being in a list. A node is completely separate from being in a list.
Okay.
Thinking about the structure, anything that has to do with how it relates to some other structure should belong in that class with that structure. It's great. These are great questions though, because these are common misconceptions that I see that create confusion when you're trying to break down a program and be able to implement it. This was a trick question. We're completely done. I do this occasionally just to see if we're all on the same page. Yeah.
Would, when we get to the doubly linked list, don't you also need a previous to know?
Yes.
Previous.
Yeah. This is why I named this class a singly linked node, because eventually we'll want a different node class to be able to instantiate a doubly linked node with a previous value. Exactly. All right. Let's actually go make the list. This is what is going to be most of our work. This is a much larger class. We're going to call this singly linked list. Again, this is just an object. It's a tool to be used. So there is going to be no main. It's all going to be defined functionality, fields and methods. So now I'm going to introduce a possibly new keyword. Has anyone heard of the protected keyword in Java? Quarter of us, third of us, maybe. So public and private, we've seen and heard, we know what those do. Public just means that this is accessible from anywhere. It's public facing, everyone knows it exists. Private means it can only be accessed or called by something else in this class, not anything outside of this class. Protected is right in the middle. It is public to anything in this package and private to anything outside of this package. This is very useful when you want to make an object or something like a linked list where there's communication between nodes and lists. And we'll see that this becomes important as we start making an iterator for this. By itself, these could all be private. Once we make an iterator, we're gonna start wanting to be able to make changes to this list from outside this list. But some other program that's using this wouldn't be in this same package. We don't want them having the arbitrary ability to manipulate this list without going through the methods that we are about to write. This makes sure that anyone who's trying to use an object that you've created is only using it in the ways that you, the designer, are anticipating. Otherwise, they could break the program, they could crash the program, they could send you a very angry email that's their fault and not yours. We don't want that. We don't want to waste our time. So, singly linked list is going to be generic, so we should also do this. We first want to make sure that we implement our interface. This is going to create a compilation error until we actually go implement all of the associated methods that we said were going to be part of anything that implements this list. So the fact that I have now broken this, that doesn't matter. I know exactly what this error means. I know that in order to make this red squiggly go away, I just need to write all of the methods that are defined in this interface. All right, let's hop into it. Our fields are all going to be protected for now. Okay. What are the fields of a singly linked list? What are the components, the state of a singly linked list?
Yeah.
We'll go 1 and 2. Some kind of head and tail. I like this. What are the variable types of the head and tail? Yeah, they're going to be generic singly linked nodes. Just going to copy because time, we're going to now have a tail. What else?
Size.
Size seems like a really good idea. What variable type is our size going to be?
Int.
Like it. It's an int because it's always going to be an integer. We don't need any of the functionality of Java's wrapper integer class. We just need the generic simple int. Yeah.
Why do we make it protected?
Just in case. So we're going to see that when we implement an iterator for this, the iterator is actually going to be responsible for manipulating the list, adding and removing things. So we're going to need to be able to manipulate the size from the iterator, which I'm going to want to put in a separate class.
Oh.
So I'm future-proofing this a little bit. Other questions before we move on? Yeah. Because we will find that if we ever want to add at the end, which is a very frequent task that we want to do, rather than starting at the head and iterating all the way through the list to get to the tail, it helps to just have a way to teleport to the tail. When we add in the middle, we don't really have an option. We're still going to have to get to that middle location. But one of the functionalities of this list is going to be adding at the end. Whenever we call that method, we want it to be as efficient as possible. It's as efficient as possible if we can just jump right to the tail. Great questions. Love the involvement. All right, next thing we want to implement is probably a constructor. We want to figure out what are the values of these fields when this object is created. So let's go ahead and write that. Any parameters needed to set this up? What should I put in here? Nothing. An empty list doesn't need any input from an outside source. It should be able to create itself in its default form without that. An empty list. What does the head look like in an empty list?
No.
It is null. What does the tail look like?
No.
What is the size?
0.
Great, constructor done. I like simple constructors. They make your life nice and easy. Question?
Why do we not need to use, this dot head or this dot tail on this?
In this one, there's no distinction between the two, so you could absolutely say this dot head equals null, this dot tail equals null. Since there are no parameters, in this case, there's no ambiguity of which one am I referring to. Here's where I'm more okay with saying just head or tail, but if we look back at the singly linked node, especially here, where one is referring to a parameter and one is referring to a field, you would want to make sure that that is the same between that. We absolutely could say this dot head, and you notice that it's blue right now, adding this dot in front of it doesn't change that at all. For me, mostly it's about the ambiguity and the ease with which to figure out what are we referring to. Either of these would be perfectly correct from my perspective.
So.
Yeah.
Just in general, if there's no parameters, you do not need to use this dot.
Correct. If there is a parameter and you're not referring to the parameter, you also don't need to use this dot, but I would argue that it eases the readability for the end user. Anyone who's reading this code, they can more quickly understand exactly what it's doing without having to ask themselves a question and figure out what are you referring to with this. It's nice and easy in an IDE with syntax highlighting, but if you're doing a code review, maybe you don't have the same development environment as the person who gave it to you. It's an assumption that you end up with. In my experience, whenever you can remove assumptions, that's usually a good thing. Yeah,
Who will be the team in
a T in anything. In this case, the singly linked list of T here is telling us what type this is going to be. When we make a constructor of this, we don't actually need to specify the T in the method itself. Whenever we're referring to the type of a linked list or the type of a node, we will need to specify it with the generic. But when we're referring to the constructor does not need the generic. Great question. Yeah,
Save us a few steps down the line if we made head equal, or sorry, tail equal to head. In the second line, instead of just making it null.
Possibly. The issue with that, I think it's exactly the same thing, because once we change what the tail is or what the head is, it's not gonna update at the same time. So you could say this, and since head happens to be null because of what it was in the previous line, this is identical in terms of what it does.
If statement when we first add, like our first node has to check like if the size is 1, then we have to like adjust the tail accordingly.
Yeah,
I was like,
okay, that makes sense. I would argue that it's gonna be exactly the same regardless of which one of these we do. Great point, though. Always thinking about that, and that's good. Thinking about ways to make this simpler, easier, and also future-proofing it a little bit, making life on us in the future a little bit easier. All of that kind of planning is something that can save you a lot of time. All right, next thing we're gonna want to add is our add functionality. Let's go ahead and figure out, there are two different ways that we're going to want to add. We want to both add in the middle and add at the end. To get a little bit of engagement going on in the class, why don't you talk to the person sitting next to you or closest to you, or turn around. It's okay if it's a group of 2 or a group of 3, doesn't particularly matter. Just work with at least one other person and see if you can draft out both of those add methods, adding in the middle and adding at the end. See if we can make it work. I'll give you 10 minutes, something like that, and we'll do it together.
given the.
Not much up to me because intelligence decided that so I have to have them email my school account so I can get and keep using the thing in the middle of each. So that was so I think what we need to do yeah, whatever the generic thing is. And then it would put it in to our head node, and then push the,
Just have one.
because our currently our head. It's no. Oh, yeah, yeah. So our element can be.
Yeah.
If it's, I mean, I think we could use. Yeah.
Oh, no, they should have done that. Equals to that. So.
Yeah.
To the point you're going to go to the. And then.
Would add.
Yeah.
Add.
And then the next thing we want to do once we grab the element that they're wanting to put in is put it into the data. Or do we want to move the head forward? And this or, sorry, you like to do that first? Or
Like, should we
It's like
first
the-
get the sizes here?
Oh, that's true, yeah. So like, no, how big the list is.
Right, so like if.
So it's like the head. Is,
Yes.
You have to have the rows. And then this one. Oh, it's. Yeah. Well.
What's it barking about?
Side. I think. And then the size.
I think we're just trying to add to the front for this first one, right?
I think this session of this just adds. And then this one adds. So I think.
Oh. Okay, so yeah, then we just have to go until the end. We just need to know the size of these.
Okay, so we can start by. Well. No, it's all right, that is.
There you go. So yeah, I think
Because then we want to. Just do critical to not. We want size.
Yeah, but I think you still need to make that note.
Yeah, right. And then.
But you're not generating them up there.
Right, so, no, I'm not, or, no, so this. This is the curve.
Yeah, because when you have the new keyword at the start. New single, cur equals the size or the head. Great.
It's basically.
Why? I don't think you know this. So I think you should. Point. Is that? E. Here we go. You have to pass element into this one and then.
So if you find the one before. Well, I would say, oh. That's not this. That's encouraging.
You mean, yeah,
There's like, yeah, I'm pretty sure.
and then we want to, so we want to iterate through our things, we want to. Or the previous node, right? Or something like that, or.
So that's.
For action, we can have. Yeah.
No, I know.
Oh, yeah.
So you can find.
Yeah, I think that works better. Yeah.
Might be a temporary.
So once that's finished, then for that, not to them. Right back in those, that was such a.
All right, as we start finishing up at least a little bit of this, I want to introduce those of you who have never seen Java comments before to Java comments. Most languages have some default way of describing what's going on in a comment form. So Python has docstring and Java has Javadoc. Most languages have some kind of standard. In IDEs that support Java, you can show that the comment that you are about to write is a Javadoc comment by starting that comment with /**. It's just adding an extra star to the block comment. And that contains a number of pieces of information that are meant to be read to summarize what this method does that doesn't necessarily require technical knowledge or the understanding of the Java language quite the level that you would if you were going to read the code. So the first line of this is a brief summary of what this method does. There are @param, this is a tag that can be used to describe the parameter. Usually you'll want to then name the parameter. So @param element tells you that I'm referring to this parameter. And then I describe what the expectation is for that parameter. What does it represent? @returns tells us what is happening when we return. What is this Boolean? What does it represent? @throws tells us what kinds of exceptions this method might throw. And instead of just saying this throws null pointer exception, we now have a description of what might trigger or cause that null pointer exception to be thrown. Some other tags that I really like to throw in my Java comments but aren't necessary are @precondition and @postcondition. These tell you what needs to be true in order to call this method. That's the precondition. And the postcondition says if all of the preconditions were met and this method is executed, what needs to be true about the program or the state of an application after this method is called. We don't make any assumption about the postconditions if the precondition met. So a potential postcondition for this is that the size of the list, if this is successfully done, if we return true, the size of the list will grow by 1. A precondition is. I don't know, what would a reasonable precondition be? What needs to be true in order for us to be able to call this add with an element?
Element can't be null.
In order to call this, the element can't be null. Let's go ahead and implement. The first thing we should check, usually whenever we have a method that's going to throw an exception of some kind, is check for that exception. We don't want to start doing any logic and manipulating this structure if the preconditions aren't met. So let's write a statement, an if statement that is going to check whether this should be a null pointer exception. So we'll ask whether element is null. If we do this, then we actually want to throw the exception. Throw a new null pointer exception, and inside of these, we're going to write something that communicates what happened. Already done. Notice that we're not trying to handle this exception in here. Whomever calls this add now is going to worry about what happens if I pass in an element that is null. From our perspective, there's nothing we can really do about that. We can't do what we wanted to do. So we should just be done. What next? What did we come up with? Say here.
If we want to first check if the size is 0.
Yeah. Well, this is going to be difficult because we could check whether the size is 0, but according to our list interface, we have a method to do this for us. So we should probably 1, implement that method, and 2, call that method. So we're going to call isEmpty. If the list is empty, then we're going to have some logic, but we should probably just very quickly implement that isEmpty because it's going to be very simple to implement. I could write a Java doc comment for this as well, but I'm going to leave that for an exercise. All right, now we have a working isEmpty. So if the list is empty, what is the logic that we need to do to add at the end of the list?
Set the add as the node we created.
Yeah, we need to create a new node and assign it to be the head. So let's go ahead and do that. We're going to assign to the head. We need to, since this node doesn't already exist, we need to call the singly linked node constructor. Now the question is, which one of these should we call? We have 2 different singly linked node constructors that we wrote. Do we care about the next value? Do we know that the next value should be something other than null?
No.
No. So that means we only need a single parameter. What is the parameter? Element. Whenever we passed into this method is going to be what we pass into the constructor. Question?
Do we also need to set it as tail, or is that just like assuming?
We will probably want to do something about the tail as well, right? Yeah, we certainly need to do that. We can set the tail to be the head. Because we just wrote the head, and so we want the tail to point to that exact same node. note that there's only one node in existence. So when we assign to tail, we don't need to make another node. There's still only one node, the single node that we are adding. We now just have two names to refer to that existing node. Both head and tail are local names for now the same node. As we add more things, the tail will now refer to a different node than the head does, but for the moment, since the list was empty, when we started this, head and tail are going to point to the same single node that we created. Does that make sense? Any further clarification I can do? Anything left to do? Return. Close.
Just increment the size.
Increment the size, yes, we do want to return eventually, but I think we want to first bump up the size and then return. What value should we return, true or false? True, we were successful, right? That's great. If you throw an exception from within a method, it's going to return automatically. We don't need to, it's just going to cut it off. We're done. Return the exception. So we don't need to return from that particular if statement. All right. If the list is not empty, what do we want to do?
Set it as the new tail.
Okay, so we want to add at the end of the list. If this is going to be the case, then we need to figure out whatever the last node is and kind of connect to a new tail. If we make a new list at the new node and immediately assign it to the tail, we're going to have lost where the old tail is and have to iterate from the head to figure out where the old tail was. So to prepare for this, we are going to store off the old tail so that we can make that connection after we do it. So we can first make the node.
Did you mean not to put a T in the triangle bracket?
Up here, it actually doesn't matter when it's being assigned to something. The compiler can figure out if we're trying to put it in head, since head is a singly linked node of T, then this must do what is going to fit in here.
Oh.
So that's just a shorthand that allows the compiler to figure out what type goes there. But in this case, we do need the T. We don't need it here, but we do need it here. So once, again, we're assigning to a singly linked node of T, the T becomes optional on the right-hand side.
While you're doing that, is creating a new node.
Yep. Right now, we're putting the value in it that was passed in, but now we have to do the associated connections. And to do that, instead of storing off the tail, we can do something a little bit more clever. Since the tail is still the old tail, not yet this node, we can set tail.next to be this new node. Now we'll reassign tail. Bump up the size. And return true. Does that make sense? So let's just quickly draw it out. I know we're just about out of time. If you have another class to run off to immediately, I'm just going to quickly draw out. We have some node. And this is the existing tail. Question? We have the new node that we created that we want to be the new tail. We made this with value element. This passes, this goes off to nothing, and this currently goes off to nothing because it is the tail. So by saying tail.next equals node, we're just taking this pointer and we're pointing it here. Tail equals node. So now we're changing the reference, instead of calling this node tail, we're calling this node is now called tail. It has two different names. And then we bump up the size and return. And now the tail is pointing to the new last node. And what used to be the old last node is now the second to last node in your list. Questions, comments, concerns? All right, we'll pick this back up tomorrow. Writing some more of our linked list. I have office hours right now in my office if you have any questions, concerns, or would like to do anything in more detail.
Quick question, no, I don't know. Yeah, how long will it take IntelliJ to send an email to your EMU account?
No idea, I've never set it up for myself.
Okay. Ah, that's so annoying.
I know.
I was,
You will be able to get by with the free version, you don't need Ultimate for anything in this class.
oh, well, I don't know if it even is with Ultimate, because all it's like, hey, you can't keep using this.
Maybe fun to download the free version.
Yeah.
Or try out this for a while, and then you can decide, do I like IntelliJ more or Eclipse more? Yeah. I was gonna say, the right answer is certainly not JGrass, but then you said that.
I was panicking, I was like, I do still have JGrass.
Yeah.